Alright, now for step 3. So step 3 is to identify dilations. And this is the hardest part of writing equations of our first 6 functions. If a function has been dilated, and dilations can include stuff like reflections, stretches, and compressions, any modification to the coefficient in front. Then what you do is you start from h comma k. You start from the point h comma k, and you move 1 unit right. I'll explain what that means when we get to the graphs down below. A, which is the coefficient at the front of the equation that we talked about in the other 2 parts, is the change in y values from x equals h, so this is h comma k, to x equals h plus 1. Which is whatever the point is to the right of h comma k. So let me demonstrate what this looks like. Okay? So let's find h comma k here. I'm going to do that in pink. So in this first example, it's a quadratic, so h comma k is right here. And it's got the points -4, comma, -2. Okay, so we know that h is -4 and k is -2. So now we're going to move 1 unit to the right of h comma k, and that's going to put me on this x value here. This x value here, which is -3. And we're going to look for where the graph is on this x value. It's right here. Now I'm going to take note of this point right here, which again is 1 unit to the right of h comma k. It is where the graph is 1 unit to the right of h comma k. So in other words, x equals h is at the x value of -4, and x equals h plus 1 is at the value of -3. So wherever the graph is at the value of h plus 1, which is -3, we're looking for the change in y values between the point h comma k and the point at h plus 1, which is just to the right. The change in y values is this change here. So how much did the y values change by? Now if you said 1, okay, we're getting there. But we're looking for the change because we're looking for a change in y values, we're also taking into account whether it changed in a positive way or a negative way. So if it went up, then we're going to say that the change is +1. But since it went down, the change is -1. Right? So the change in y values here, which we're going to call a, is equal to -1. And again, that's because a, the coefficient at the front of the equation, is the change in y values from h comma k, or whatever the point is at the x value of whatever h is, to the point to the right of h comma k, which is whatever wherever the graph is 1 to the right of h comma k. And again, it went down by 1 when I went 1 unit to the right. When I went 1 unit to the right, as we go 1 unit to the right, the graph goes down by 1, so a is -1. And now we can write the full equation of this graph. So we have a, which is -1. Well, let's put the y equals first. And we know that this is a quadratic, so it's going to have something like that. -1 goes out front. Now, do I have to write the -1? No, I can just write a negative sign instead. But we know that a is -1. A is -1. because as the graph goes 1 to the right, it goes down by 1, so a is negative 1. Then we have x minus h. So because h is negative 4, we have x minus negative 4. So that's going to be x minus negative 4, which is going to be x plus 4. And then k is negative 2, so we've got plus k in the equation, so we're going to keep the sign the same. The only one that really flips around is h. K keeps its sign the same. And so we end up with y equals negative, parentheses, x plus 4 squared minus 2. And this lines up with what we learned about transformations, right? Because it has a left shift 4, which is where the x plus 4 comes from, a downshift 2, which is where the minus 2 on the end comes from, and then it has a reflection across the x-axis. So that's where the negative comes from. Alright, let's do one more together. And then I want you to pause, and I will show you the solutions one at a time for these remaining 4. So we've got this point h comma k. At the point of inflection this time, we're dealing with a cubic. I should have left a little bit more space there for a, but that's alright. Leave a little bit of space between the equals and the parentheses. Alright, h comma k is at 2 comma negative 1. As we go 1 unit to the right, we're going to meet the graph right here. And as we go 1 unit to the right, we go 1, 2, 3 units up, which means that our change in y values is positive 3. Our change in y values is positive 3, because as we go 1 unit to the right, we go up by 3. And just for clarification, because these functions are not linear, the rate at which they change is not constant. So, in other words, this only works if you're going 1 to the right from the point of inflection here, or the vertex, or whatever h comma k is for that particular function. This only works when going 1 unit to the right. I'm not going to go into the reason why it only works going 1 unit to the right, but it only works going 1 unit to the right and not 2. So, because a is 3, there's a 3 at the front of this equation, which is why I said leave a little bit more space. There's a 3 at the front of this equation. Yeah, nope, that's better. Then we have x minus h. H is positive 2, so we have x minus positive 2. X minus h. And then plus k, which is negative 1, so it's going to give me minus 1. Okay, I want you to pause the video and take some time to write the equations of these remaining 4. I'm going to go through them one at a time so that you can check yourself. Alright, I'm going to write number 3 now. Okay. And we're going to go 1 unit to the right. This is going to go up a quarter. keep in mind we can only go 1 unit to the right because, again, these aren't necessarily linear functions. This one is. But, so we can't treat this like slope. With absolute value, we kind of can, because it's like two linear functions put together, but you can't always do it that way, as you'll see in example 6. So we get positive 1/4 is the change in y values from h comma k to 1 unit to the right. As we move 1 unit to the right, we go up 1/4. And this is absolute value. H is 0, so all we need to put is x. We don't need to put x minus 0, but we can if we want. And then plus 1 at the end. Alright, linear. H comma k is at the y-intercept. We get y equals, well, hang on. That's a change as we go 1 unit to the right, we go up by 2. So that's A. We don't really need an x minus 0. And we go minus 2. 2x minus 2. And this lines up with what you learned in Algebra 1 with slope-intercept form, because the slope is 2. And the y-intercept is negative 2. Alright, and lastly, the point of inflection for number 6 is right at the origin. And as you move 1 unit right, you go half a unit down. Because it's halfway between 0 and negative 1. And this is a cube root function, so we get y equals negative 1/2 the cube root. And to write cube root, you nest the 3, which is called the index of the root, within the little v part of the root. And now, because the origin is h comma k, all we need is x here. Because it's really x minus 0 plus 0. And we don't need to write any of the zeros, because it doesn't change anything. And there you go. That's how you write the equation of a function.